All right, this is a hopefully quick video to kind of talk a little bit about the electromagnetic radiation spectrum and in terms of memorizing it as well. Okay. Um, in my history of teaching physics and seeing the diploma exam, um, it's very rare, or I can't even remember if there is a time when a student had to know a specific frequency or wavelength and what that type of radiation that was associated with that, right? Um, the thing that we do see frequently is understanding the visible spectrum, more specifically the ends of the visible spectrum, the red end and the violet end, and then the two types of electromagnetic radiation that kind of are on both sides of those, the infrared and the ultraviolet. And so with my students, I typically stress that part of it. But I also do stress that you do know the order of the electromagnetic spectrum as well. So I'm going to go through that, kind of how I would recommend memorizing that. And then I will also kind of give you a little bit of a trick in terms of memorizing the frequencies. And once you know what the frequencies, then you can determine wavelength fairly easily as well too, right? We know from our universal wave equation, V is equal to frequency times wavelength. And the speed is always going to be the speed of light, right? So if we know the frequency and we know the speed of light, then we could determine what the wavelength is if you get a question where they're asking about the wavelength. Okay, so that's what I'm going to do in this hopefully short video, and then hopefully it helps you out a little bit. So the very first thing that I would say is that when we look at the electromagnetic spectrum, and I'm actually going to shift over to this one here first. Okay, zoom in a little bit. The very first thing that I would say is, like, it's important for us to understand the electromagnetic radiation spectrum in terms of energy. Okay, so on one side we have high energy, and I would put that over here, high energy, and then on the other side we have lower energy. Okay, higher and lower energy. Okay, and I think this one that I have on here kind of has that as well too. They show you the energy of one photon in electron volts here. So this is 10 to the -9, and then over here is 10 to the 6. This isn't a bad spectrum chart. There's a whole bunch of them. I just grabbed this from Google, so you can find whatever one you want. But if I was writing a test or the diploma or whatever, and I'm kind of having trouble with the electromagnetic spectrum, the very first thing I do is take a blank sheet of paper and I'd write on the right hand side high energy and the left hand side lower energy, and then right underneath that I would put the frequency, and frequency is directly related to energy, right? E is equal to hf, as we've learned with Planck's constant and everything, right? So here we have lower energy, so we have low frequency, and then we have high frequency over here. Okay, so high energy, high frequency, low energy, low frequency. And I would probably leave it at that. But if you wanted to put the wavelength on there too, just so that you have it for reference, remember wavelength is inversely proportional, right? If we wrote this, it'd be HC over wavelength. So that's inverse. So where we have low frequency, it would be higher wavelengths. Or maybe just use the symbol. Higher wavelength, right? And here we're going to have a lower wavelength. Okay, and you can see the wavelengths on the top here. On the left-hand side, it's 10 to the 3, and then on the right-hand side, it's 10 to the -12. So we don't usually use the word higher and lower. We use longer and shorter because it's a distance in terms of wavelength. But if you want to kind of stay consistent with the high, and low sort of a thing, then you can do that as well. Okay, so that's the first thing that I would do, is I would just separate my page to the left-hand side and the right-hand side in terms of energy. The next thing that I would do is I would actually draw my visible spectrum. So what I would do, I'm going to switch over to here, is I would have my visible spectrum, and actually this visible spectrum is flipped. They have this. We have this the opposite way that it should be. So let me. Oh, sorry. I'm trying to flip it, but maybe that's not a good idea anyway. No. It's okay. I'm not going to, maybe I just won't use that on here, but we can take a look at the visible spectrum on here. Okay. So what I would do, and maybe I'm going to go to a blank piece of paper. Let's say this is your blank piece of paper. So I'm going to start here, low energy, low frequency, right? And then higher wavelength. Then over here, high energy, high frequency, and then low wavelength, okay, or shorter wavelength. Okay. And then what I would do is I'd put in the middle here my visible. Okay. Now you do have to remember which end of your visible is higher energy and lower energy, right? Um, so that is something that you do have to memorize a little bit. And the way that I usually explain it with students is like we know that there's the red and the violet end, right? Roy G. Biv. So one end is going to be lower energy, one's going to be higher energy, right? So when I say before I write this on here, like Roy G. Biv, right? The next part of this that we're going to talk about is like what comes after this part of the visible, right? Well, there's violet here, so there's ultraviolet, and then on the other side there's red, so it's infrared. And I usually say, using your knowledge that you have already of these types of radiation, which of these is more dangerous? Infrared, remember, is heat, and ultraviolet is radiation from electrons, but it is ionizing radiation that can cause skin cancer, right? So clearly, UV radiation is higher energy and more damaging, right? So that's the way that I kind of remember that violet is on the end of the spectrum with the higher energy, the higher frequency. So when you write it in terms of your visible in here, okay, you do write it in the terms of Roy G. Biv. So that's why I like to write it with low energy on the left and high energy on the right, because then Roy G. Biv is in the order that it should be. You don't have to write Roy G. Biv backwards, right? So I'm trying to give you, some advice in terms of if you're trying to write this out on a piece of paper, you're in a test, right? And you're trying to memorize it, right? Lower energy on the left, higher energy on the right, Roy G. Biv in the middle there. And then you can write on here infrared and ultraviolet on either side. Okay. So that kind of gives us our big framework here. And in terms of wavelength, because you do need to know this, the red end of the spectrum is 700 nanometers and the violet end of the spectrum is around 400 nanometers. So we go beyond that, and then we're into ultraviolet and infrared. Okay. And like I said, I'm going to show you right at the end this in terms of frequency, how you can kind of remember the frequencies as well. Okay. Okay. So, if we're trying to remember then the order, and that is important, I believe, for you for this unit here. Okay, we know that we still have obviously lower energy and then higher energy electromagnetic radiation to add to this list here. Okay, so another thing that might be helpful or easy to memorize is like your lowest type of energy and your highest type of energy to put on the ends as well, right? So we go to our chart here, right? Our lowest types of energy that we have on here are radio waves. Okay, radio, TV waves. It depends on what you're talking about or who you're talking to, but we usually call them radio waves, radio/TV. Okay, and then on the other end of the spectrum are our high energy, and that's our gamma rays. Okay, and that's our ones from nuclear energy, gamma radiation. So again, it's sometimes easier for us to kind of fill in the pieces instead of going from left to right when we're doing this. We know the lowest energy TV radio waves. It's sometimes referred to as long wave radiation, okay, because of the wavelength. And then we have this gamma radiation that's on the other side of it, okay. And then so we have our middle part, we have our end part, and now we just have to fill in the in between. Okay, which is pretty easy because we only actually have one more each in between that we're going to fill in there, right? So between infrared and radio waves, we have microwaves. And remember, microwaves are not ionizing radiation. They cook our food, but they don't have enough energy to ionize, atoms. Okay, so they can't, they're not cancer causing in that regard. Okay, on the other end of ultraviolet rays, we have probably one of the most common ones that you're familiar with is X-rays, right? That, we talk about with the Compton effect and all of that as well, right? So that's our spectrum here. You can see here, radio waves, microwaves, infrared, visible, ultraviolet. They split them into soft and hard X-rays here, and then gamma rays. Okay, so here is my spectrum from low to high energy, from low to high frequency, or from long to short wavelength. Okay. So again, I'll just repeat that. I know this is supposed to be a short video and it's already getting long, but start with your visible, Roy G. Biv, reading it in the middle there, okay? And then go on to either side of your Roy G. Biv. So you have on the red side, you have infrared, and on the right side with the violet, you have the ultraviolet, okay? Then put your endpoints on. The lowest energy is radio, TV, long wave radiation. Okay, you know that it's the lowest energy as well too, because you flip on your, the radio, or you turn on a TV or whatever, and there's not a lot of radiation there. It's not like it's giving you cancer or anything by doing that, right? As opposed to if you turned on the other end of it, gamma radiation, then you would have to be shielding yourself from it. Okay, so fill in your endpoints, your radio, TV waves, and then gamma rays on your right hand side, and then all that you have left is your microwaves and X-rays. And again, X-rays are dangerous. You have to wear shielding when you get an X-ray, so it fits on this right-hand side of the spectrum. And then microwaves are not as dangerous, right? You don't have to put any shielding on before you pop something in the microwave, so it's lower energy. Okay. Even though the visible isn't really dead set in the middle, I kind of treat it as the middle. And to the right of that is like your ionizing radiation, your harmful radiation, and to the left of it isn't. And that's a way, in my mind, that I'm very easily able to differentiate between these different types of radiation. Okay, so that's what I would say in terms of memorizing that. Now, really, like I said, I really don't think you need to memorize anything specific about this other than red is 700, violet is 400, infrared is a little bit bigger or higher than 700, ultraviolet is a little bit lower than 400. I think you would probably be okay with that. Okay. However, if you are, want to be, cover all your bases, make sure that okay, there's an easy way to remember frequency. Okay, and I like wavelengths better than frequency because of the visible. We use the wavelengths more, but this is an easy way to remember frequency. And like I said, if you know what the frequency is, you can just pop it into the universal wave equation and find out the wavelength. Okay, and here's the little trick. Okay, it's not exact, but it's close enough that it works. Okay, we start with 10 to the 8 for the frequency, 10 to the 8 hertz at radio and TV waves. And each of these types of radiation, it goes up by 10 to the power of 2. So microwaves is 10 to the 10, infrared is 10 to the 12, visible is roughly 10 to the 14. Okay, and these fit over a spectrum, right? So this is around what they are. Ultraviolet is 10 to the 16, X-rays is 10 to the 18, and then gamma is 10 to the 20. Okay, that's really easy to remember, right? It's not really a whole lot to remember ranges and all of that sort of thing. I want to show you something as well, just to kind of reiterate this point of that I don't really think that you need to know that either, right? By the way, that's what this little chart I put up on here too. If you want to just take a screenshot of it or whatever, it helps you to see that as well too. But they're all going up by 10 to the power of 2. If you remember that you start with 10 to the 8 on your lowest and go up that way. But I really stress this with my students as well too, is that when we look at these different types of radiation, there's a lot of overlap in these. Okay, we see overlap here. We see, well, this is all X-rays. So X-rays is overlapping with gamma rays and all this sort of stuff, right? So if you were to be asked a question about what type of radiation this is just based on the frequency or the wavelength, they would have to have it in a place where there isn't overlap, which is kind of a cheesy question anyway, in my opinion. And the reason for that is that we don't actually classify electromagnetic radiation based on its wavelength or its frequency. I mean, it's a property of it, there's no doubt about it, but we actually classify it on how it's produced, right? So each of these is produced differently. And that is important that you do understand, how each of these are produced. Okay. So I'm going to go through that really quickly as well too with you if you haven't studied that or you're unfamiliar with that, and then that'll be it for this video. Okay, when we look at radio TV waves, right, we talk about charges being accelerated through an antenna. Okay, so accelerated up or down an antenna. Also, with some of these really long wave radiation, we just have basically AC current is producing this type of radiation. So remember, in alternating current, electrons are going back and forth 60 times every second. Okay, and that back and forth is creating an electric field, which is creating a magnetic field, electromagnetic radiation. So AC current or charges up and down an antenna are creating radio and TV waves. Okay, in microwaves, we have somewhat similar, except that we have vacuum tubes in which their current is being accelerated as well too. Okay, so we use vacuum tubes. to accelerate charges. Sorry, this is kind of messy. I don't even know why I'm doing that. Okay. In terms of infrared radiation, we have the vibration of atoms. Okay. And again, in Science 10, you will probably remember learning about how kinetic energy and the motion of atoms are equivalent to each other, right? So that's infrared radiation. When we look at that, is actually like heat, right? So that's the kinetic energy of atoms, which is heat. Okay. Visible spectrum is electrons jumping from one energy state to another. So, if you took chemistry, you know this in a little bit more detail, but if only you took Science 10 before physics, you remember that Bohr energy level diagram where we have electrons in different energy levels and they can go up and they can go down. Okay, so when they go down from one energy level to another, they give off energy, and that is in the form of visible light if it's within that range, right? Now, ultraviolet radiation is the same thing, but they're having bigger jumps. So they're going from, if you have that energy level diagram, you have an electron near the top and it's jumping all the way back down to the bottom. So there's more energy being given off at once, as opposed to just jumping, from one energy to another where it's less energy. And then that would be in the visible state. And I should say with this as well too, all of this energy around the visible, even infrared, you can produce infrared radiation that way as well too, with really, really small amount of radiation from really small jumps of electrons from higher energy to lower energy levels. Okay, so really all these ones in the middle that we drew in the middle are kind of produced the same way as well. Okay. X-ray radiation you talk about a lot more with the Compton effect and how it's produced, but X-rays are by accelerating particles through electric fields. Okay, and then slamming them against the surface. So essentially, we're increasing the kinetic energy dramatically over a short period of time, and then we're decreasing the kinetic energy to zero over a very short period of time. So all of that energy that was kinetic energy then is released in the form of electromagnetic radiation. Okay, and then gamma radiation is from nuclear decay. Nuclear fission, I should say, etc. And you'll learn more about that in Unit 4 if you haven't talked about that already. Okay, so that's really how we categorize electromagnetic radiation. It's more on how it's produced, not on its wavelength or its frequency. But because those types of the way that we produce them, will produce them to be within that specific range, right? Then it is possible for you to memorize what the range is in terms of wavelength or frequency, and then be able to classify is that X-ray radiation or infrared or ultraviolet or whatever. But like I said, my experience with the diploma exam, and I've been teaching for almost 20 years now, I cannot recall a question where they were nitpicky about a type of radiation. Maybe once, but even then, if it takes you a long time to remember all the different wavelengths and frequencies or whatever, it's probably not worth it just for that one question. You probably would be able to isolate it nonetheless, especially if you remember this whole 10 to the 8, 10 to the 10. I think if you remember that, then you're golden. I wouldn't go any deeper into memorizing wavelength ranges or anything like that. Okay. I hope that was helpful, and I'm not good at making short, quick videos that are really succinct, and I apologize for that, but I hope that this video was helpful, and that it helps you to kind of remember the electromagnetic radiation spectrum, remember how they're produced, the energy, and like this chart right here can help you in terms of remembering what the frequencies are of them. So if you ever did get a question where they ask you specifically, where is this in the electromagnetic spectrum, then you can answer that. I didn't go into detail in here in terms of the different colors, right? And I've never seen that before either, right? I've only seen where they show you kind of on the ends of the visible. So like the violet end or the red end of the spectrum, right? Not like where does green begin and yellow, end and that sort of a thing. I've never seen that. And I I really wouldn't spend time memorizing that. But if you really want to do that, then you can go onto Google and you can find those charts. The only thing I'd warn you is that they're all slightly different, right? So it can be a little bit frustrating memorizing those charts about where one wavelength starts and one wavelength ends, sort of a thing. But that is up to you. Hopefully this is helpful. And if you have any other questions, please don't hesitate to ask.